They say we should have known better than to fall so deep down into this rabbit hole we found. And I was thinking...
Hi, this is Nikolai, and you're listening to my dad, Rafal, co-host James Jardine, and featuring Mr. Jim Tiller on the one and only Down the Security Rabbit Hole podcast. Plug in, listen up, and enjoy.
Deep into this pool of regrettable situations. Pitch black, think back to the last time that we were happy.
Good morning, good afternoon, and good evening. Welcome down the Security Rabbit Hole to yet another edition of the Down the Security Rabbit Hole podcast, cybersecurity's favorite podcast, 700 plus episodes and a lot of years running. Thanks for listening. Good to have you aboard. I have an interesting topic of conversation today. As I say often, some of these podcasts just start with a really interesting blog post or something interesting in the conversation stream on LinkedIn. This one came from LinkedIn. I saw Josh post something, thought, that's interesting. Grabbed another friend of mine, Jason, and we decided, let's talk about it. So first and foremost, introductions. Jason, go ahead first.
Thanks, Raf. Good to see everyone. Jason Vest, CTO at Binary Defense, come through security by way of some time in the Air Force in the back end of the AWACS, Airborne Warning and Control System, followed by some time as a special operations pilot. Did some work doing digital forensics for the government, Child Rescue Corps, a special program there, and then pivoted into a cyber career, done consulting, ran security ops for companies, and now playing at Binary Defense, trying to keep up with Dave Kennedy and all the fun things he's doing there. So I'll pass it over to you, Raf.
There is no keeping up with Dave Kennedy. It's like somebody gave a squirrel way too much Red Bull, and it's just, dogs go squirrel. No, squirrels don't go squirrel. Squirrel just go. There's no keeping up with Dave. I now know firsthand. But
first place
it's fun to try.
First place where the performance review is based off of how much you grew your biceps in the previous year as well. So that
I love it. I'm working on it.
Yeah,
I'm nowhere near you.
Next year it's going to be down the security swole.
I love it.
Yeah.
All right. Wow. Before this gets weird, Josh, go ahead.
Sure. Yeah. Thanks, Raf. And thanks for the opportunity. I've enjoyed your podcast for a long time now. So it's great to be on. I am a statistician, and I started my career at Los Alamos National Laboratory. I spent 15 years with the field intelligence element of the Department of Energy, which means we protected U.S. national security secrets and also worked with the Five Eyes. After a brief stint at Ernst & Young, they had licensed some of the technology I invented. So I went over to Big Four Consulting. Then I ran the Microsoft Defender for Endpoint data science team for several years, chief scientist at Securonics, and now founder of Alpha Level.
Love it. So as I hinted at the beginning, there was you put up a relatively interesting, caught my attention anyway, LinkedIn post on detection AI. Give us a quick summary and we'll kind of jump off from there.
Yeah, it's meant to be a bit salacious. I tend to be a little bit salacious in that, I claim that AI SOC as it is today, or maybe more particularly automatic alert triage, is a Band-Aid on a problem that is actually earlier in the detection pipeline. And that is that we're not very good, or we could be a lot better at pulling the raw signal out of the noise earlier before the alert is created. And that a lot of this sort of effort to fix up our alerting is artificial, and that where we should be focusing much more energy is earlier in the threat detection pipeline.
Okay.
And I could go on, but I'll pause there.
Jason, any thoughts on that?
Yeah, no, a lot of thoughts. And now that I hear your full background, Josh, I'm just going to walk away and give you the floor. But I'm curious to dig into that a little bit more, Josh. So are you saying earlier in the detection life cycle, we're moving away from are moving towards things like anomaly detection and, the big data model, where some of the people are like, send it to my black box and then let me apply data science. Are you saying changing the perspective, changing where you put the data together at the source? Like now, obviously with AI, you can, everything through API connectivity, you have access to the data. Yeah. So I'm curious, are you, part of what you're spurring here is the question, which I agree with, it should be changed. We're definitely missing the mark. They're honestly re-engineered because of what we can do with AI. But yeah, curious what your thoughts are there.
Yeah, let me try to say something cohesive or coherent. So rules encode expert knowledge and therefore are fundamental and profoundly needed. We got to have the encoding of what we know is bad. Actually, in the early part of my career, I wasn't sure we needed that, but I have matured in my old age and admitted to myself that an army of expertise, which is looking at the threat landscape, determining what queries, basically rules we need to develop to encode that expert knowledge, is absolutely fundamental and required. Whether that detection engineering is done by a human team or an AI team, I'm happy. We need to encode what we know is bad. Okay. But that's where we stop a lot of the time, and that's insufficient. Rules tend to be fairly precise in that, I can write down a thing I know is bad and then go search the data. They can be very rigid, or they are rigid, in that if it doesn't exactly match the thing, I'm going to miss it. Of course, the adversaries are motivated to do something that we didn't know about, because if they do something we do know about, we're going to catch them. So you can be pretty precise about what you know and then have low false positives, but then you're going to have a lot of false negatives because you've been so precise in the definition of your rule. On the other side of the coin, you can be fairly general with Boolean logic or a rule or a query, and then you're going to get a lot of false positives because it's too general. And what I've sort of observed over my career is that finding the sweet spot between those two is kind of impossible. You can't ever really get that right. So more broadly, I don't think we should stop at presenting an atomic match with a known bad thing or suspected bad thing to a human or AI analyst. I think here's something, I'll try to say something salacious. I think alerts need to die in a fire. Okay, let's see if we get some podcast folks to argue with me on that. But stopping at that point and showing either a human or an expensive AI, that alone is ridiculous. Okay, so then the next thing that we do is, and I helped build the XDR for Microsoft, is write rules to combine stuff together. Okay, and that's what you might call an XDR. And now I can combine multiple of these relatively weak signals together and not show an analyst or an expensive AI, the individual atomic things, but hopefully eliminate a bunch of false positives by combining stuff together and getting consistent evidence that this is all pointing towards an attack and malicious. And that should reduce false positives and accelerate analysts in arriving at the true positives. What did the attacker do? What's the kill chain? What's the attack story? What holistically, what did they do? But again, that rigidity of the predefined rules for how one combines things together. If I see, the stupidest thing that most XDRs did right out of the beginning was, okay, if it's the same user with two different alerts within 5 minutes, combine them together, right? And that's again sort of a static way of defining, what to do with all this telemetry. I'll provide an alternative. The context available to determine whether something is malicious or benign is only there when the action's happening. predefining what to look for, well, who knows if it's true or false until you have the context of the whole enterprise at the time that that thing happened. So I think generally one of the innovations that I'm happy to see in terms of AI triage is that that is a process that's examining the context around an alert at the time that the alert happens and not at the time that the detector was defined. So I think that's profound, whether we use a large language model or an agent or some other technology. The important thing here for me is that we're looking at the dynamic context available at the time of the alert as opposed to predefining everything at the detector definition time. And now I'll just stop because I said a whole bunch of stuff and I'll just pause.
Yeah, no, at face value, I'm tracking what you're saying. And that's where Raf and I were discussing potentially maybe some alternate approaches. It's kind of like when we talk about 6 months ago, people were saying what we're seeing out of AI is probably going to fulfill the promises of SOAR. Now I would say 6 months fast forward, AI is obviously what you can build with AI, some of the ways you think about workflow, some of the things you can do with AI. It's probably going to make SOAR irrelevant. And yes. I would argue the same approach to how we've looked at detection engineering as a community. We don't need AI to make detection engineering better, to make our behavioral detections tighter. I think we actually need to step back and approach how we look at, like you said, and this is where we agree, the entire context. And the context is a lot greater than what you see in a SIM. With what you can do with agentic technology as well, you can go get more context than we've ever been able to get and put all of that information together, make a decision, go get more information, make another decision all immediately, something that a human couldn't do. So because of that, it's kind of like if you think about AI, in my opinion, is one of the biggest transformations since, I've heard somebody say, since gunpowder. Like, we're talking about muzzle loaders here, how we look at detections. Let's put gunpowder in a muzzle loader. We're not even into like a 50 cal Barrett, or we're not even to like the M4 or semi-automatic.
I like these analogies.
Need to re-engineer. Yeah, there you go. We need to re-engineer as a security community. Now we have all of these tools available. And the way some of the things that the people I'm working with are looking at is we're calling it a situation. It's not a detection, not an alert, not alarm. I love when you said alert should die. And obviously, we'll see where the SIMs go and the SOARs go from there. But at the same time, let's get the information and then let's apply a new application of determination. We're going with situation. Well, it's the situation, but obviously that's just tons more context than we've previously got in the past.
Yeah.
Hey, can I throw in, because I'm probably, you guys, I'd qualify me for the ability to talk intelligently here, but I'm going to throw an everyman's comment here. I think when I think about detections, right, there's still some fundamental way we have to figure out what's normal, what's abnormal, which one of these is not like the other, what doesn't belong. I think the identifying bad, and everybody used the bouncer example in a nightclub, like determining what was bad probably stopped being useful around the time of semantic antivirus in about 2002, right? Like, we went from hundreds of thousands to tens of thousands to hundreds of thousands, and like it just became impractical. Some version of that persists today. But with all the machine learning and the ability to create statistical models based on which assets do what kind of communication at what time, in what way, with what payload, over what protocols, in what duration, like all of these things, these metrics matter. And when you start modeling this, do we have the horsepower to do this kind of analysis at a scale that could look at like a typical, we'll say a typical mid-size enterprise and model all of their traffic? Because I imagine that from a statistical perspective, that model gets really, really large, really fast.
Yeah.
Is it economical? Like, is it feasible?
Well, today? This is definitely, Josh is going to have a great answer with a data science background, but this is what people have been trying to do with data lakes, data science, anomaly detection, pre the AI boom recently. So yeah. Josh, I'm very curious to hear your perspective on how AI is really enabling this.
Well, so, I mean, that's what my PhD dissertation was on, was modeling of network pairs of communicating computers and then forming them into a graph and identifying lateral movement. It's basically anomaly detection. And then as a young, starry-eyed researcher, I thought, okay, let's have a model for everything. And the models are running all the time, and they're updating, self-updating. We're methods and statistics for exponentially weighting the past and learning the future and forgetting the past, and very sophisticated stochastic process models that I think have been poo-pooed because AI is a shiny thing, but this is very sophisticated mathematics and statistical modeling. And so I, had this ambition that I'm going to take over the world with models for everything. And I'm going to have a score for any time something significantly changes. The probability that this is coming from the model is very low, right? And so I've learned what's normal, excuse me. And then I can score everything in the entire enterprise. Yeah, that doesn't scale. You nailed it, Ralph. That's expensive and noisy, and you're subjecting yourself to false signals a lot. And there's something called the multiple testing problem that will basically magnify your errors if you do this and stuff. So that's something I had to go at, and then was sort of had to think more deeply about it. Nowadays, where I'm at is sort of triggers. So consider that a rule could be a trigger, an alert could be a trigger, or more generally, what we do is sort of just-in-time modeling. So we get something that causes us concern. And I'll give some examples. So a rule or an alert. An anomaly on some subset of data, for example, authentication data logins. Okay, yeah, we probably should have models for every user. This is the UEBA thing. Have that running all the time. That you can afford that. You got 20,000 models for a 20,000 person organization or something like that. And you can with Spark and some good hardware, you can keep up, and it's not too expensive and so forth. And then those anomalies would then trigger, or alert matches or something else would trigger more deep modeling. Now, then the models need to be lightweight enough that they can be estimated on the fly.
Right.
Like within 5 milliseconds or something, the model's up, and it can score the data that is in front of it and then die. And you get the score, and then you can combine it with other scores and stuff, but you don't have to maintain the model for scale at all times. You kind of use some triaging of lightweight, inexpensive models on certain things, plus probably the rules. Take those alerts. Those are very valuable. And that can be the triggering system for scaled anomaly detection, wrapped right around the anomaly or the alert. Just look around it. What did the user log into? What processes did that machine run? What other machines connected to it? And maybe like a 1-hop or 2-hop context graph around the trigger is sort of the idea.
That sounds good at a interaction level based on either, I think, human or maybe even machine, right? At a where am I logging into from an identity perspective? What am I doing? I think that starts to fall apart in terms of just the sheer capability and the sheer model size required. We're talking packets, right?
Yeah.
When you look at like a system or an IP address on the network, let's take it down. Let's look at a MAC address on the network, right? It pulls an IP address. It starts doing stuff. It's never like a packet, a packet, a packet, a packet. It's like, 10 meg, 20 meg, 10 meg, 5 meg, 1 meg, 200K, 200K, 10 meg. Like, it's doing rapid exchange of packets. Modeling that with all the bits that requires in terms of, right? Like the source destination, port protocol, payload size, all that, even if we scale that down, I think it's doable on a smaller scale, but it starts to collapse when that model gets huge, and I don't think there's a way to build it just in time.
Well, I want Jason, I'll give you, Jason, you some space. Let me just jump in for a sec, because this is actually my dissertation work. So I feel really strongly about network modeling. So certainly stay at the metadata or net flow, sort of router collected layer 4 statistics on connections, right? You can't afford to, but I'll give you a head trip. Look, I think every electron that we could measure, electrons of an enterprise, has some probability of being malicious. So where do we start worrying? Well, we got to be practical about that. Get to some level of resolution, logs, metadata, raw packet content. Yeah, that's for a monitoring system. That's very expensive. You want to have these things go to some static analysis. So once you find there's evidence, okay, you can get a payload and reverse engineer it or something. That's a very expensive manual process, but you don't do that in a scaled monitoring setting. Yeah.
Yeah, no, I think we're on to something. Thank goodness it's your dissertation, Josh, because there's some credibility behind where we're headed. But what I'm seeing too, it's kind of funny, the ramp up of, like I mentioned, with let's do a data lake so we can do our own anomaly detection, or even some vendors use that as their way to find outliers. Again, that's just based off of single points of context. For the most part, there's some behavioral patterns in there. But then we really open the aperture with what we can do as far as a behavioral analysis of all the context. We're not just looking at network traffic. We're not just looking at endpoint traffic. We're looking at behavior across an enterprise of an attacker and building models around that. So like just take an isolation forest, for example. I mean, in the most simple form, you're just isolating anomalies. Now we've moved into a space where we can gather a lot of this information, go get more information if we need it, bring it back to some of this data science approach. And what's funny about it is we're experiencing that too, is you've ramped up a lot of AI technology and AI expertise, but guess what? You still have to go back to traditional data science to do something with it. And so the door is revolving around in that factor, but they really are dependent on each other. I just don't think we're thinking big enough with what we can get our hands on with AI to apply and reinvigorate some of the original data science work that we've learned. And that's, I think, where Josh was headed. So yeah, I'm excited. And it was in the post a little bit. It's in your dissertation. In that context is again, we're very much narrow focused on the traditional behavioral detections, the traditional data we have. And as we all start training our private models and we look for new ways to detect malicious activity, again, like call it maybe like a situation where you're looking at what happened in the past 24 hours, 48 hours, past week, and you're able to make a decision based off of that. And it's not just one data source. That's like thinking big. That's like getting out of the muzzle loaders and into the 50 cal, right?
Something like gunship missiles.
There you go. AC-130. That's a good one.
Yeah.
So
infantry support.
Do you guys remember the days where we went from like, so insecurity? I feel like we've the pendulum has swung multiple times. We went from log everything to, oh my God, that's too much. Select what you log selectively, turn everything off until you need it, to this is the cloud, log everything. Space is unlimited. Space is cheap. To, oh my God, we don't even know what to do with all of this. Stop logging. Now, where are we now?
Yeah. Well, now we're by data management, so we can minimize but still have access and control the data pipeline to save money. But then, no, that's a good point, Raf. And I'll second that with another topic that's similar as a security community that I think is worth noting in this. Just like we were with Red Intel and sharing, if we can come to a point where we share some of these AI models and AI concepts as a community and don't move into, monetizing it over basically advancing the community, we could really, and I bring this up, I think this is what happened just by necessity in the 90s with the fraud space. They had to come up with a model. Otherwise the credit card, 1 in 100 transactions in the 90s, I think was fraudulent. If they didn't work together, it wouldn't have survived. I'd like to see the same with some of our AI modeling and these discussions that we're having with Josh, like for us all to come up with something we're able to work on together.
Yeah. Generalized modeling frameworks are attractive to me, so, if I could provide the community with, you push a button and 1 million models get built, run on the data, give you scores back out. Now you've got a tool you can apply to lots of use cases, right? And we've done some of that, but I may be digressing from you guys' point, but I have not. I have a very high bar for what's a good model, and I have been a part of less than good, modeling, and there's a reason that the hedge funds pay a quant, which is sort of my profession. That's sort of a statistician. Sort of, if I wanted to make the most money I possibly could, I'd do that. But these people are making seven figures, and the reason is that they're very, very good at modeling. Modeling is actually a very hard thing. You have to understand the aspects of the data that matter, what we call the data generating process, and I think we have underestimated that as a security industry. And I've seen engineers, and I am almost an engineer myself. I've hang out with engineers. I write a lot of code, but we have used engineering trained folks for something that's really the domain of another specialty. And I think that's a natural consequence of IT. Security was born from IT, which was born from computer scientists. And so now they build a lot of the machine learning and stuff. But I have yet to see very high quality stochastic process models applied to threat detection, except what I've been doing. And now I'm probably going to get an email from somebody that's listening to say, I did it and here's my work and it's good. And so I don't mean to insult anybody, but broadly, I think we've not done well enough. And these packages, like just use the latest whatever isolation forest or whatever and apply it to the data and see what you get. I think we can do better than that, but it actually takes skilled people to do it.
Well,
people like
I've repeatedly heard the quote, all models are bad, some are useful, right?
Yeah, that's a statistician who said that.
Yeah, that's right. And I have a particular love for creating models of things because behavior is an indicator. At least it's not a conviction, but it's an indicator. Just because I'm walking in that direction doesn't necessarily mean anything. It's just it gives you some weight or some direction or some idea. I don't know where this ends up in the future because I like the idea of creating a series of models that's like essentially open to the community to raise the tide so all boats lift. Yeah. Right? I'm going to ask this. I know the answer to this. I'm going to ask this anyway. Do we think this industry can stow its ego long enough to cooperate?
That's a great question. Well, before I answer that too, I would say because I would say I wish we could, and I'll be a proponent of that. But it goes back into transparency of AI, what you're using, and the question should be to vendors: can you show me your model validation process? Right? Why would we trust someone to protect our environment when I'm a buyer if I can't show you how something as simple as I validate my models? And if there's not a governing standard to do that, should we create one as a security community and then in that use that as an opportunity for collaboration? That might be a gate into it. Yeah, I mean, I think we've done some of that. We tried to do some of that with threat intel sharing and different models there between the Diamond model and some of the other things we do with Taxi and Sticks. I think with AI, it's going to be birthed. And yeah, Raf, I mean, if I had my way, we would do this as a community and not as a vendor-led approach.
Yeah, agreed. I think there's a certain, for the common good, we must ... right? And then we can monetize on top of that the implementation of and the things around it. But at some point, when you have the formula for the cure for cancer, it needs to be opened to the world because the greater good has to win. I've been doing this for long enough to know I don't think we have enough. I don't think we have enough integrity as a community at large. I'm sure I'll get plenty of hate mail for this, but I just don't think as a community by and large, because of the money involved, we'd rather continue to sell aspirin and help the patient feel comfortable while they're slowly decaying rather than helps address the root cause. But that's my cynical opinion. I'll tell you what, we're down on time. So I'm going to give you guys, 60 seconds kind of final word on this. Yeah. And since you opened, Josh, I'm going to give Jason, I'll give you a minute to give me your thoughts, and then we'll go to Josh, and then we'll close.
Okay, yeah. It was a good time. Great to meet you, Josh, and we'll stay in touch. A lot of fun topics there. Thanks for the time, Raf. And I'll just kind of close on, I'll tell you what, I'll be optimistic, Raf, because you do watch the CISO community as a whole. We're stronger together, and I think that has evolved, at least for the companies I've worked with too on the vendor side. We'd rather make the world a safer place than put monetizing things over. So I'm gonna leave that an optimistic approach that as we launch into the future here with what we're doing with AI, we're going to be willing to share if we've got a model that we think is the pinnacle and it's going to help. I could see some ways for us to share that and get that out there and collaborate with guys like Josh, for example. So I'll leave it with that. But yeah, it was a fun pod. Thanks, Raf.
Yeah, it's good to meet you too, Jason, and I am detecting a friend and collaborator, so I'm happy about that. And I've always been an open source guy, so I certainly echo that sentiment. I'll sort of go back to the original thesis and just remind everybody that, yeah, I think we have a lot more work to do in the left. Raw telemetry, threat detection, extract a signal from the noise. And I want to educate or remind the community, don't forget about that, because I think that's where we're going to get the biggest bang, and that the AI for system 2 sort of triage, automatic response, SOAR functions, great, amazing. But we're not done with that system 1 threat detection bit. There's my thesis.
I like it. That's a good place to end. Josh, thanks so much for spending your time and sharing some of that. Mm-hmm. Jason, thank you for jumping on and giving us some of your time. And of course, thank you for joining us and listening along. If you get a chance to drop us a comment, leave us a review, let me know what you think of the show. These guys are on LinkedIn. You'll find them both. I'll post in the show notes for those of you that read. They'll link to the original LinkedIn post so you can follow that along. And until next time, we'll catch you guys another time, another place on another Down the Security Rabbit Hole podcast. It's ciao for now. We'll see you guys later. Bye-bye.
This is Bella. Thanks for listening. Don't forget to leave my dad a review and share this with your friends. Bye.